Hello, great people. How are you? Mr. New Love is here again. If you've not watched the previous series or the previous videos, try and watch it. This is series 5. Okay. In our previous video, we were looking at this question, the last question on differentiation from the first principle, and we explained all this. And this was the final answer we got. So today we are not going to talk much here. We are going to look at differentiation using the notation. You see that the first one, it was from the first principle. So if you are asked the question to differentiate this one from the first principle, you have to use this method. So you cannot use this method if you don't see from the first principle. So anytime you hear from the first principle, you use this method. Now there's another differentiation. That one is very short, is by using the notation. Using the notation. That's the next thing we are going to look at today. So the notation there, we have different forms. The first one, if the question is given this way, like find the derivative of f of x is equals to something, like f of x is equals to 5, f of x is equals to 2x plus 3, f of x is equals to 1 over x. Yeah. This is how you should answer. You should write what? First, or f prime, which means the first derivative. First derivative. So here, the f, you write the f. If it is j, you write a j. If it is k, you write k. If it is m, you write m prime. So now this one is f, so we said f prime. If it is k, you write k prime. If it is h, you write h prime of x is equals to whatever answer that you have. We'll look at the answer. We'll look at how to do it. Now we are only looking at writing the notation. Then if the question is also given this way, y is equals to, let's say, 2x squared plus 3. Find the derivative. In other words, find the derivative of y is equals to 2x plus y. Another way they can put the question, if y is equals to 2x squared plus 1, find dy dx. If you are asked such a question, to answer this, you write dy dx is equals to whatever answer that you find. If it is m is equals to, you write dm dx. If it is k is equals to, you write dk over dx. Okay. Then if the question is written this way, dx into brackets, let's say x squared plus 1, they will just write this one without anything, without derivative or whatever. You just write equal to, then you differentiate, which will be the next thing to do. Alright. Okay, so this is the notations. Then the next one, the rules of differentiation. These are the rules. If you want to find the first derivative of a constant, let's say 2, 5, 8, 12, it's always equal to 0. Remember when we were using the first principle and we were told to find f of x is equals to 2, we got our final answer to be 0 after going through that long step. Yeah, so these are the rules. Okay. Then f prime ax is equals to a. What does it mean? If I have f prime 2x is going to be 2. F prime 12x is going to be 12. F prime 20x is going to be 20. Then this is the general formula. After differentiating from the first principle, your final answer in a short method or in a short way is this one. What does it mean? F prime of ax exponent n is equals to the n will come and multiply the coefficient of x. So n a or a times n. X, then your exponent you say minus 1, n minus 1. So if I have 2x to the power 3 is going to be 3 times 2 x n minus 1. What is our n? To the power 3 is 3. So 3 minus 1, which is 2. Okay. We'll do more examples on this using numbers. And you will see what I'm talking about. So if we have f of x is equals to minus 2, it means f prime is equals to 0. This rule. If you have f of x is equals to 4x, it means f prime x is equals to what? 4. That rule. If I have this one, f of x is equals to minus 3x squared plus 6x minus 9. These two will multiply this minus 3. It will give us minus 6. Then you write the x. Then 2 minus 1 will give you what? 1. X to the power 1 is x. Then the exponent here is 1. So 1 times 6 is what? 6. X. The exponent here is 1. So 1 minus 1 is what? 0. So x to the power 0 is what? 1. So it's like 6 times 1, which is 6. Okay. Let's move on. Okay. Now differentiation rules, looking at the examples. If I have f of x is equals to x minus 1 times x minus 2, the first thing you need to do is to expand. So you have x times x, which is x squared, x times minus 2, which is minus 2, negative 1 times x will give you negative x. So minus 2x minus 1x or minus 1x or minus x is going to give you minus 3x. Then minus 1 times minus 2 will give you plus 2. Okay. Now we want to differentiate. If you are having problem expanding this, inbox me. Now to differentiate this one, these two will multiply 1 here, so you have 2x. 2 minus 1 will give you 1, so x to the power 1, which is the same as x. Then 1 times minus 3 will give you minus 3, that is x. To the power 1 minus 1 will give you 0, so you have only minus 3 here. This plus 2 will blow away because it's a constant. Remember, we said if it's a constant, the rule says it's 0. If it is minus 3, the rule says minus 3. If it's minus 3x, the rule says it's what? Minus 3. So we are using the rules here. Okay. Then this one. We have f of x is equal to 1 over x. This is the same as x to the power negative 1. This x, if it comes out, this is positive. The exponent here is positive. When we bring it up, here is going to be what? Negative. So to differentiate this one, it's going to be negative 1 times 1, which is negative 1. There is 1 in front here. We have our x. Then negative 1 minus 1 will give you negative 2. Then the next one,